Now we shall go to the design, steel frame design and view revised preference. So in here we do need to select the AS4100 2020, and we can do the general second order analysis, and framing type is basically our we can say moment frame or braced frame. So we shall be proceeding right now with moment frame, because in one direction we do have braced, but in the other we only have a moment frame. And these are the capacity factors, that is for bending, compression, tension, flexion and shear. These are the 0.9. We do have to consider the deflection check, and after that the dead load limit has been assumed as 120, live load has been assumed as 360, and total limit that has been assumed as span divided by 240. And pattern live load factor and demand capacity ratio limit, that is the maximum utilization ratio cannot be greater than 0.95. So we can left click on OK, and we can do need to select the design combinations also here. So in here, if we are talking about the, we can say the strength design. So in that case, we can remove the serviceability load combination. So in here, we can remove all of these serviceability load combination values, and we can select the strength design values. And under the deflection parameter, we do need to take all the serviceability load combinations on the right hand side. So now everything is okay, and we can go to the design, steel frame design, and yeah, but before that we do need to analyze the structure also. So we can go to the run analysis option. So on the center we can see that under the dead load case, it is approximately deflecting by 3.3 mm, and we can, we have already although checked the local parameters in the other videos, but just for the sake of confirmation, we can go to the deform shape here, and we can go to the combo, and in here we can select the one-time dead load plus live load. So in this particular case, the deflection of the center is 7.488 mm, and that is like quite less if you're considering such a long span of 20 meters. And we can check the first mode shape also, and the natural time period also of the structure. So the fundamental time period that is coming is 0.565 second. So coming to the design calculation, we can go to the steel frame design, and we can click on start design check. So we do need to ignore these purlins here, as these are already designed in the X-Factor software. So we can select all the remaining parameters for the design. So what we can do is that we can go to the select and properties and frame section. Under this we can select the C150 1.0, go to select and close. Then we can go to the invert selection option, and we can go to the view and show selected objects only. So with that, we can see that now we have already only selected the the members that need to be designed. So if we are right clicking here, let us say under the 250 by 250, here we can see that the utilization ratio is only and only 0.1. And if we can click on the overrides here. So under the overrides option, we can see that our compression capacity is 1698 kilonewton. Tensile capacity is also in the same approximate range. Major bending capacity is 135 kN meter. And in here, if we want to see the maximum chunk of utilization, it is hardly 0.043 in the, we can say, compression axial load, and 0.052 in the major, and 0.005 in the minor. So let us say if we check it with the lesser size also, let us say of 150 by 150 by 6 also. So in that case also, it is like ratio is quite controlled, that is only 0.137. And if we, let us say, go ahead with 100 by 100 by 5 square hollow section also, in that case it is going a little bit higher, of approximately 0.493 utilization. So what we can do is that is a repeated cycle of permutation and combinations that we do need to continuously change. So let us say if we are first of all talking about this particular case, that is 150 by 100. So we can reduce the size of this member. So instead of 150 by 100, let us say we proceed with 100 by 100 by 5. So in that case, it is approximately 0.6. So this we can, go to the select and properties and frame section. In here we can select 150 by 100 by 6, select and close. We can go to the design, steel frame design, and change design section. Under this option we can select 100 by 100 by 5. So we can again click on the steel frame design option. So now we can see that all of the members, the sizes are changed. Right, that is from, we can say, 150 by 100 to 100 by 100 by 5. And after that we can click on this particular member also, that is 200 by 100 by 6. If we see the utilization, it is hardly 0.37. So we can check it with the lesser section size also, that is, let us say, 150 by 100 by 6. Again it is 0.441, which is we can say quite a controlled value. We can check it with 125 by 125 also. Now it is 0.509. So we can change all of these members, that is 200 by 100 by 6. We can click on this 200 by 100 by 6, select and close, design, steel frame design, change design section. Under this option we can select again this 125 by 125 by 5. So we can again click on the steel frame design option, and now we can see that all of the members have been, we can say, the sizes have been changed. After that we can optimize the size of the bracing also. So in here we are having approximately 200 by 200 by 6. So instead of that, let us say we proceed with 125 by 125 by 5. So here also the bracing is quite controlled, that is 0.181. And if we proceed with the minimum size here, that is, let us say, 100 by 100 by 5, then also it is 0.272. So that is like, we can change that. And after that, let us say we right click on this main member, that is 250 by 250 by 6. Instead of this, let us say we change it to 125 by 125 by 6. So then also it is 0.363. So this is up to us at how we can optimize, and if required we can decrease the size of this member, because right now it is looking, we can say, somewhat over designed, because all of the ratios are like quite less here. Here also it is 250 by 250 by 6. We can change it to, let us say, 125 by 125 by 6 also. So then also it is 0.498. So with all of these optimizations, what we need to do is that we do need to repeat the process of applying the wind load, because the earlier wind loads are considering that the section size is 250 by 250. But after the optimization, let us say if we're talking about this particular bottom member, we can go to design, steel frame design, and change design section, and change all of these sections to 125 by 125 by 6, and click on steel frame design. So with these kind of cases, we can further do the optimization. And here also you can see that how the end member is, the ratio is quite high, because this is the member that is taking all the pull at the supports, but it is still again lesser than 0.95. so we can proceed with that. We can go to display, force test diagram, and frame pier spindle link forces. The important thing that we do need to understand while designing these kind of truss structures is the understanding of the axial forces here. So we can left click on apply here. So here also you can see that under the application of the, what we can say as the gravity load combinations only here, this is the axial force diagram that we are having. So if we click on this particular number here we can see that it is 254, and in here we can see that it is approximately 81. So what exactly is happening here is that this yellow color denotes tension, that is, the member is in tension. So both of these members are in compression because of the configuration of the geometry. After that, the tension increases at the center, and it simultaneously decreases and then converts into compression at the ends. Similarly, the whole top part of the truss, that is again is in, we can say, compression only, and all the bracing members, that is the one that are diagonal and are highlighted in yellow, they are in tension. So the thing is that, we have designed it, and this is a very solid structure, and here you can see that we can decrease the size of this foot overbridge also, and we can do the further optimization also depending on the, we can say, requirement. So this is how we can design the foot overbridges and understand that the results, that whether we are getting correct or not. Here also you can see that this particular part, this is in, we can say, compression only, because ultimately these are the members that are transferring the load from the deck to this particular joint. And if you want to see the reactions on the ends, so what we can go to start, we can go to display force diagram and support spring reactions. We can click on combo, and we can just switch on the FZ, that is a vertical. So here we can see that it is approximately 125 kilonewton of the axial force at the supporting points. So that is hardly 250 kilonewton, and that is a very lesser load if we are talking about the design of the concrete foundation at the bottom also. So this is how you can design and check the results of the foot over bridge.